Okay, so we're gonna quickly finish up the second part of 1.3, and that is compound interest. Compound interest, so if you remember this, the equation went like, if we had the initial amount, and we are going to compound interest. So compound interest generally obviously means it's gonna be a positive thing. It's gonna be an exponential growth, right? So if I had our annual percentage rate, and I'm gonna compound this n times per year, this is what it looked like, right? I don't know if you guys remember this, so let's go for an example. If we have $1,000 and I go ahead and invest this in a annual percentage rate of 6%, and if I compound this quarterly, like 4 times a year, so it's going to be 4 over here and divide that by 4. Okay, so you're going to end up with something that looks like this, 1.015 to the 4th. Okay, that's how it would look. If I'm going to do this, compound this monthly, what would I change here? Natalie, how would I change this if I'm compounding this monthly?
You would add, so right now it's by day?
Huh?
Right now it's by day?
Right now it's a quarterly compounding. So every quarter we're compounding it. So if I'm going to compound it every month, how many times do I end up compounding it for a year?
12.
12, right? So wherever it says 4 here, I'm going to change that 4 to 12, right? So I'm going to do that, and it's going to look like this. This would be what we would do if we were to compound it every month, right? Okay. So if I'm going to compound this daily, okay, I am not going to use 365. The bank says there are only 360 days a year. So it's going to be 360, and that's how they're going to work. So we're going to do this. If we're going to compound this daily, this is what it looks like. We can also continuously compound, right? Continuously compound. In other words, I am going to compound this 1,000 times. Let's say it's 1,000 times a day, right? 1,000 times a day. So it's going to be what? 360,000, because that's how many times I'll be compounding it for a year. And I'm going to get 360,000 down here, right? In other words, this portion here is going to be 1 plus r divided by n to the n. If I go ahead and take the n infinity to infinity, limit as n goes to infinity, this ends up being what? E, right? This ends up being e to the r, is what it ends up being, okay? It becomes e to the r, okay? E. So anybody tell me anything about e? What is e? Why is it called e? Does anybody know? Didn't we have this discussion? E, it's called E because it is right? How do I pronounce this, Sam?
Not the way you think you would.
Oh, not the way I think I would. Kayla?
Euler.
Euler. It's Euler's number, right? It's Euler's number. This is Euler's number. Euler is the one who developed or found out about this number. It is 2.718281828, and on and on and on. Okay? All right? So this is what Euler's number is, okay? That's the E, okay? All right. Let's see. So if I'm going to go ahead and, so if I'm going to compound this continuously for, let's say, for t years, okay? For t years, my initial equation that looked like this guy is now going to become, for continuous compounding, this becomes e to the r, and if I'm going to do this many years, t years, this is what's going to look like, okay? So this is the continuously compounding equation. This is what this looks like, okay? So if you flip to page 26, top, there's a green box which shows this equation. See if we can use that. So if we can use that in example number 5. Example number 5. Bernice deposits $2,500 in an account earning 5.4% annual interest rate. Find the value of the account in 10 years if it is compounded daily. So 10 years compounded daily. A, I am initially investing this amount, 1 plus, and it is a APR of 0.54%, but I am doing this 360, doing this daily for how many years? 10 years. So I actually compounded it, this 360 times 10. So the thing up here is going to be 3,600. So that's how I would calculate that. Okay. The book says 365. If you go to the bank's only give you 360. Okay. Now on B, it says, what if we do it continuously compounded? So it's going to be 2500. I put in this equation here, e to the 0.0, oh, what am I going to get here? Where am I at? 0.054, right? But I'm going to do it for 10 years. So I'm going to multiply that by 10. And that would be the answer. Okay? Which one do you expect to be larger here? Continuous compound is going to be compounding many more times compared to this. So you're going to get a little bit more of this from this than you would from this. As a matter of fact, let's go ahead and see what we have. It's going to be a grand total of 17 cents more over the course of 10 years. You would get 17 cents more here compared to that. Okay? Any questions there? Do you have any questions? Does this ring a bell? I mean, we've done this.
So would the difference between the two totals, would the difference between the totals be greater if it was like compounded like quarterly?
Yeah, so if the A was compounded quarterly versus this, you would see quite a bit of difference there, right? Because during the 10 years, you would be compounding it 40 times here compared to greatly amount of times over here. So you would see a bigger difference if you were compounding it only quarterly in part A. Yes, that is correct. Okay. Okay, I'm done. So you guys can continue to start working on the homework. Continue to work on the homework. And again, I will be here to answer